to Cognitia Podcast.
Hello, everyone, and welcome back to the Cognitia Podcast. Every week, we bring you some new insights into the world of emerging technologies. We have an absolutely mind-blowing episode for you today, and trust us, you are going to want to stick around for this one. So grab your coffee, settle into your favorite chair, and let us dive right into something that's quietly revolutionizing how millions of Indians travel every single day. Picture this. You walk into an airport, approach the security checkpoint, and instead of fumbling for your boarding pass and ID while juggling your luggage, you simply look at a camera for 2 seconds and walk through. No papers, no queues, no stress. Sounds like science fiction? Well, it is happening right now at 24 airports across India, and it's called DigiYatra. Today, we are unpacking one of India's most ambitious digital identity projects that has already processed over 48 million passengers. Yes, you heard that right, 48 million. And is fundamentally changing how we think about identity verification in the digital age. We are going to explore not just the technology behind this marvel, but the incredible engineering challenges, the psychological barriers that had to be overcome, and why digital identity systems worldwide could follow DigiYatra's footsteps. Let us start with the big picture. DigiYatra isn't just another government digitization project. It is a complete reimagining of passenger processing at airports. Launched by the Ministry of Civil Aviation, this system allows passengers to use their facial biometrics as their boarding pass and ID, creating a seamless, paperless airport experience. But here is what makes this truly extraordinary: the sheer scale and complexity of what they have achieved. We are talking about a system that needs to accurately identify individuals across diverse lighting conditions, from the harsh fluorescent lights of airport terminals to the natural sunlight streaming through massive glass windows. It needs to work for every Indian face. And if you know anything about India's incredible diversity, you will appreciate just how monumental that challenge is. The system integrates with multiple databases in real time, cross-referencing passenger information, flight details, and security clearances while maintaining strict privacy protocols. And it does all of this in seconds, processing millions of passengers without breaking a sweat. Now let us talk about something that does not often make headlines but was perhaps the biggest challenge of all: changing minds. You see, technology is only as good as people's willingness to use it. And when you're dealing with something as personal as facial recognition, trust becomes paramount. The DigiYatra team faced a fascinating psychological puzzle. On one hand, Indians have embraced digital payments through UPI with unprecedented enthusiasm. On the other hand, facial recognition technology carries baggage, concerns about privacy, surveillance, and data misuse that were amplified by global headlines about Big Brother-style monitoring systems. The breakthrough came through what the team calls experiential trust building. Instead of launching with fanfare and promises, they started small. They chose a handful of airports and focused obsessively on creating experiences that were so obviously beneficial that word of mouth would do the marketing for them. Think about your typical airport experience. The anxiety of potentially missing your flight because of long queues, the constant patting of pockets to ensure you haven't lost your boarding pass, the juggling act of documents while managing luggage. DigiYatra eliminated all of that friction in one elegant solution. The team also made a crucial decision early on: radical transparency about data usage. Your facial data isn't stored centrally, it's encrypted and stored on your device. The system only creates temporary digital tokens for verification, which are deleted after your journey. This wasn't just good privacy practice, it was smart psychology, giving users control over their data. But perhaps the most brilliant aspect of their approach was making it optional while ensuring it was superior. You could still use traditional methods, but once you have experienced the DigiYatra flow, going back felt like choosing to take the stairs when there's a perfectly good elevator right next to you. Now, let us dive into the technical marvel that makes all of this possible. The infrastructure scaling story of DigiYatra reads like a masterclass in distributed systems engineering. When you are dealing with 48 million passengers across 24 airports, you are not just building an app. You are architecting a distributed computing ecosystem that needs to perform flawlessly under massive, unpredictable load patterns. Airport traffic is not uniform. It spikes during festival seasons, holiday periods, and even varies dramatically throughout each day. The team built what they call a federated processing architecture, Instead of one central server trying to handle all verification requests, they distributed the computational load across multiple nodes, with each airport maintaining its processing capacity while being able to seamlessly communicate with the broader network. Here is where it gets really interesting. They implemented predictive scaling based on flight schedules and historical data. The system automatically provisions additional computing resources before passenger surge periods, kind of like having a restaurant that magically adds more tables right before the dinner rush arrives. The API interactions were particularly challenging because they needed to integrate with multiple existing systems: airline databases, security clearance systems, immigration records for international flights, and more. Each of these systems had different protocols, response times, and reliability characteristics. The solution was an ingenious middleware layer that standardizes all these interactions while maintaining redundancy. If one airline system is slow to respond, DigiYatra can verify passenger information through alternative pathways without the passenger ever knowing there was a hiccup. But the real magic happens in the facial recognition system itself, and this is where the story gets fascinating from a machine learning perspective. Training a facial recognition system for India isn't like training one for any other country. We are talking about a nation with over 1 billion people, representing hundreds of ethnic groups, speaking thousands of languages, with facial structures that span an incredible range of characteristics. Add to that the variety of skin tones, hair textures, facial hair patterns, and cultural accessories like turbans, hijabs, and tilaka, and you begin to appreciate the complexity. The DigiYatra team approached this challenge through what they call inclusive dataset construction. They didn't just collect photos, they systematically ensured representation across every demographic dimension they could identify. This meant coordinating with communities across India to gather training data that truly reflected the country's diversity. The diversity in faces was just the beginning. The system also needed to work under incredibly varied environmental conditions. Airport lighting ranges from the warm, dim ambience of premium lounges to the stark industrial brightness of security checkpoints. There are backlighting issues near large windows, shadows from architectural features, and even the challenge of recognizing faces partially obscured by masks, a requirement that became critical during the pandemic. The team created what they call environmental adaptation algorithms that can adjust recognition parameters in real time based on ambient conditions. The system doesn't just take a photo and try to match it. It analyzes the lighting conditions, adjusts its recognition thresholds accordingly, and even guides users with subtle visual cues to optimize their positioning for the best recognition results. One of the most impressive aspects of their approach was handling edge cases, the scenarios that occur rarely but can completely break user experience when they do happen. What happens when someone has undergone significant weight loss or gain? What about aging? Injuries that temporarily change facial appearance, makeup styles that dramatically alter facial features. The system maintains what they call adaptive biometric profiles that can accommodate reasonable variations in appearance while maintaining security integrity. It is sophisticated enough to recognize you whether you're clean-shaven or sporting a full beard, but robust enough to reject attempts at spoofing or impersonation. The distributed computing architecture deserves special attention because it represents a fascinating case study in building resilient systems at scale. DigiYatra processes don't just run on a single server or even a single data center. They are distributed across a network of computing nodes that can dynamically balance load and maintain service even if individual components fail. Each airport essentially functions as a node in a larger network, capable of independent operation but benefiting from shared resources and intelligence. During peak travel periods, airports with lighter loads can contribute processing power to those experiencing surges. It's like having an intelligent traffic management system for computational resources. The team also implemented something called edge processing optimization, where facial recognition computations happen as close to the user as possible rather than being sent to distant servers. This reduces latency, the time between when you look at the camera and when the system responds, and also enhances privacy by minimizing the distance your biometric data travels. Let us talk about the technology stack because it is a beautiful example of choosing the right tool for each job rather than falling in love with a single technology. The facial recognition algorithms are powered by deep neural networks, but these are not off-the-shelf solutions. They are custom architectures that are designed specifically for the challenges of airport environments. The database layer uses a hybrid approach, combining traditional relational databases for structured passenger information with NoSQL systems for handling the massive volumes of biometric templates and transaction logs. The API layer is built on a microservices architecture, meaning each function, passenger verification, flight validation, security clearance, etc., operates as an independent service that can be updated, scaled, or maintained without affecting the others. Real-time processing is handled through event-driven architecture, where each passenger interaction triggers a cascade of verifications and updates across multiple systems simultaneously. It is like a perfectly choreographed dance where each step triggers the next, creating a seamless experience for the passenger while maintaining rigorous security protocols. The security architecture deserves special mention because it implements what cryptographers call privacy by design. Your biometric data is never stored in raw form anywhere in the system. Instead, it is immediately converted into encrypted mathematical representations that can be used for matching but can't be reverse engineered to recreate your actual facial features. What makes DigiYatra particularly remarkable is how it positions India as a global leader in practical AI implementation. While other countries debate the ethics and implications of facial recognition systems, India has built one that processes millions of people monthly while maintaining strong privacy protections and user consent protocols. The ripple effects extend far beyond airports. The technical solutions developed for DigiYatra are already being adapted for other high-volume identity verification scenarios, from metro systems to government service centers. It's becoming a blueprint for how to build inclusive, scalable, privacy-respecting identity systems in diverse societies. Looking ahead, the potential applications are staggering. Imagine extending the seamless identity verification to hotel check-ins, event venues, or even retail experiences. The infrastructure and learnings from DigiYatra could enable a future where your identity verification is as simple and seamless as unlocking your smartphone with your face. But perhaps the most important lesson from DigiYatra isn't technical. It is about trust and adoption. They've proven that even complex, sensitive technologies can achieve mass adoption when they solve real problems, respect user privacy, and deliver experiences that are superior to existing alternatives. The success of DigiYatra represents something profound about India's digital transformation. It's not just about adopting technology, it's about adapting technology to Indian conditions, challenges, and value. It's about building systems that work for everyone, not just the tech-savvy elite. As we wrap up today's deep dive into DigiYatra, the key takeaway isn't just about facial recognition or airport efficiency. It's about how thoughtful engineering, inclusive design, and respect for user privacy can create technology solutions that truly serve society. The next time you are at an airport, whether in India or anywhere else in the world, and find yourself standing in a long queue with your documents in hand, remember that somewhere in India, millions of passengers are walking through airports with nothing but their faces as their tickets. That is not just technological progress, that is a glimpse into a more seamless, more human future. And with that, we come to the end of this week's episode of the Cognitia podcast. We hope you enjoyed this journey into one of India's most impressive technological achievements. DigiYatra proves that when you combine cutting-edge technology with a deep understanding of human needs, you can create solutions that transform entire experiences. We will be back again next week with another fascinating exploration of emerging technologies that are shaping our world. Until then, keep innovating, keep questioning, and remember, the future is being built today, one breakthrough at a time. Happy learning.